Good afternoon from Singapore, ladies and gentlemen. A warm welcome to the Deep Tech Summit 2020, presented by SGInnovate at Switch. Our panel today will focus on the emerging hydrogen economy. I'm a professor in the Nanyang Technological University, and it's really my privilege to host this panel with the members from CSIRO Australia, which is Patrick Hartley. Pras Ganesh is representing Toyota Daihatsu Engineering and Manufacturing, as well as Toyota Mobility Foundation. Vaitea Cowan is an entrepreneur who handles hydrogen-related topics, and Mathias Steck is representing DNVGL Energy. The theme of this year's Deep Tech Summit is on leveraging innovation in science and technology to build a more resilient and sustainable future economy. There are many indications pointing towards hydrogen as the next big thing as the world shifts towards a low-carbon future. The Hydrogen Council is a global consortium that envisions that by 2050, hydrogen would provide 18% of the world's total energy needs, and the world market would hit $2.5 trillion and create 30 million jobs globally. There are several countries all around the world who are positioning to advance the use of hydrogen. Australia aims to be a global player by 2030. EU has announced a climate neutral target for 2050, and hydrogen will play a key role there. Singapore has signed an agreement with 5 consortium partners, including 2 Japanese players, to essentially explore the use of hydrogen for a low carbon economy in a city like Singapore. Biden on the 5th of November announced famously that in exactly 77 days, the US will rejoin the Paris Agreement. Mr. Biden has also announced the use of renewables to produce hydrogen at a cost target where it will be compatible with shale gas. Lastly, Prime Minister Suga announced a carbon neutral target for Japan by 2050, where a significant role would be played by hydrogen-powered fuel cells. Hydrogen is a very complex subject. And I think the audience, not all of you may be subject matter experts. So in today's session, we have divided the panel discussion into 3 parts. The first part will be a primer for about 20 minutes, introducing hydrogen for you all. The second part will be a question and answer, where we will do a quick deep dive into various issues from techno-economic analysis to research targets to end use relating to hydrogen. Finally, I'll invite the panel members to wrap things up. Before I begin, it's really my pleasure to invite, firstly, Mathias to start with a primer relating to hydrogen. Mathias, over to you.
Yeah, thank you very much, Professor Subodh, for the introduction. And thanks for having me here. Yeah, I start with a brief primer. So hydrogen is a matter which has been discussed in the last couple of years, I can say, as one of the hopes for the energy transition. Also, I guess we had with the issue that the topic was also overhyped, but we are at a stage now where we have a chance to really take the benefit of hydrogen. And the future of hydrogen really goes together with how the future of natural gas, renewables, and carbon capture and storage develops, because they come all together. And maybe just as a very brief thing, to summarize, we all know since decades the gray and brown hydrogen from natural gas and coal. That's something which we have under control. And no, that's not going to help us in the energy transition and decarbonization. We have something which is called the blue hydrogen, which is basically made the same way, but combined with carbon capture and storage to then take the carbons out of the hydrogen. And then we have the green hydrogen. And I think what we have seen in the past was that green hydrogen was discussed a lot at this big chance. But what was always the issue was, how do we get to a stage where we come to an also economically viable solution here to produce great amount of green hydrogen. As an introduction, what Europe is playing or trying to do, Mr. Subodh just mentioned our plans to some extent just now. You see here the targets of Europe. I will not read them point by point. In short, it's basically 6 gigawatt on electrolyzer capacity and capacity for importing 40 gigawatts of hydrogen, but then also investing into projects where we can produce 40 gigawatts renewable hydrogen. And as was mentioned before, carbon neutral, 80% of gas consumption in 2050 should come from renewable sources. But how do we get there? That's an interesting thing, and I think that's mainly what I want to talk about. Maybe you could go to the next slide. From the NVDL points of view, the success of hydrogen will be based on these 4 enablers. So maybe I start with the infrastructure first. Hydrogen can easily ignite. It has a bigger explosion capacity. We had an accident in Norway, actually, not far from our headquarters, where hydrogen fuel station exploded. Fortunately, nobody seriously injured. But you can see there is infrastructure and safety problems if you integrate it into society. And what we want to do from hydrogen is that we wanted to decarbonize mainly, maybe as a first step, the non-electric sector, so like transport and heat. So we kind of need to get it to the people. Leading me to the safety part, we do a lot of tests there in actual houses which we built for that purpose. How do we handle hydrogen also in a residential environment? What are the risks? How do we mitigate this? And one thing what we have to have in mind, we will not be able, from a cost perspective, probably to just build a completely new hydrogen infrastructure. So we will have to use existing systems. There is a lot of discussion about blending, for example, natural gas with hydrogen. What are the levels? It will depend on the system we are talking about, the location we are talking about. So these are things which we have to do at the moment. And what is important, I think, to understand is that we get away from this discussion only green hydrogen. We believe we need the blue hydrogen, so the decarbonized one, so to say, as a transition to build the required volumes to also get to interesting economic models. And I think here it's so important that we then come to also the right policy. So carbon needs the right price, I think, unfortunately, but understandably, as long as it is cheaper to just emit carbon into the air, that's what the people will do. So we need to find the proper price on carbon so that the CCS build up will happen and is attractive. That will allow us then to create substantial amounts of blue hydrogen. We will have to do something about the pricing. So, for example, contract for differences, that people don't have so much risk if they build facilities to push the hydrogen industry. And maybe as an overview, I stop it here and lead you over to my colleague, Patrick Hartley from CSIRO Hydrogen Industry.
Well, thanks very much, Matthias, and yeah, my pleasure to be with you here. Yes, my name is Patrick Hartley, as the professor said. CSIRO is our national research agency in Australia, for those that don't know, and within that I lead our CSIRO Hydrogen Industry Mission, which is a new initiative in CSIRO this year, which focuses really on delivering research development and demonstration partnerships, really with the goal of enabling the scale up of Australia's hydrogen industry. So I'll carry on a little bit with this introduction to hydrogen. I guess where I'd like to start and highlight is that hydrogen can play many roles in decarbonising our energy and industrial sectors, and these are shown here. Many of these applications will be familiar, but perhaps less obvious are the opportunities in some of the associated sectors, such as in my own sector of research and development, but also in areas like new technology manufacturing and services. So really quite a large number of ways hydrogen can play a role in decarbonising our society. So yes, back to those definitions, and Matthias has largely covered these already, but I'll just recap on those. And of course, these definitions really refer to the way or come from the way hydrogen is produced. So when we talk about the grey and brown hydrogen, we're talking about fossil fuel derived hydrogen, and specifically fossil fuel derived hydrogen where the CO2 is not abated, it is simply released. And of course, that's really not where we want to be, because that's a zero-sum game when it comes to decarbonisation. There's no benefit to those. That said, that's the way hydrogen is produced globally in large quantities right now. So a lot to learn from that industry, and so there's around 75 million tonnes of of hydrogen produced using these technologies every year. And so there's a lot we can try and do with these things. And of course, that blue hydrogen pathway where we decarbonize the fossil fuel hydrogen using carbon capture and storage and maybe even carbon utilization to sequester or remove that carbon dioxide from the emissions is a major pathway, certainly in that transition, as Mathias has said. The other technology pathway, which is the renewable or green technology pathway, as Mathias has said, involves the use of a very different technology. It involves the use of electricity and electrochemical cells to split water into its constituent atoms or molecules, hydrogen and oxygen. And in doing that, there's no carbon involved, so there are no emissions. And so that's why this is a pathway which is particularly being developed at large scale now to try and decarbonize the hydrogen production. So green hydrogen is where it's at the moment. I'll just touch a little bit now on some of the issues that we identified. So this is work that we did in 2018 in developing Australia's national hydrogen roadmap. And I won't go into the detail of this slide, but what it shows is that the competitiveness of hydrogen is different from a cost perspective, from a production cost perspective, in the different applications where it might be used. And without going into the detail, as I say, you can see the applications at the higher end of this graphic really are where hydrogen is already cost competitive from a production cost perspective. The applications at the lower end, there's work to do to get the price of hydrogen down so that it can compete in those areas. But of course, those production costs, the production cost of hydrogen is not the only story. There are other barriers to the utilization of hydrogen in industry, and those are things like infrastructure. That infrastructure has to be built, and when you're talking about transport, of course, that infrastructure really relates to the ability to refuel vehicles. So that refueling infrastructure is a clear priority if those transport applications are going to be realized. And yeah, there's as you can see again, there are a number of applications which can come online as that cost of hydrogen comes down, as we're all projecting through the green hydrogen pathway in particular. Just in terms of where I come from in the research and development world, this is another report that we put out in late 2019, which focuses in after the roadmap, looking at where the research and development opportunities are, particularly from the Australian perspective. And you can see a couple of things you can see from this graphic. One is that there are opportunities across the value chain for reducing those costs and improving efficiencies, be they in production, storage and distribution, utilization, and in what we call cross-cutting RD&D, which is some of that area that Mathias really touched on around things like regulation and safety, and social license to operate is another big one there as well. So there are opportunities across the value chain, but also specific opportunities for the different value chains the specific value chains, the specific application areas that are particularly of interest in Australia, which are shown there on in the center of the graphic. Export, the use of hydrogen in gas networks, in transport, to stabilize particularly electricity systems, and also its traditional use as a feedstock in industrial processes. So I might leave it there and pass over to Vaitea. Thank you.
Thank you very much, Patrick. Hello to everyone, and thank you for having me here today. My name is Vaitea, and I'm one of the 3 co-founders of Enapter. Enapter designs and manufactures AEM electrolyzers. The AEM is an absolutely unique technology, and we believe that this technology can fast-track green hydrogen scaling. While the AEM has been in R&D for more than 10 years, in 2017, we stepped in to commercialize it. Enapter is a young company with production in Italy and offices in Germany, Russia, and Thailand. Our mission is to bring down the cost of green hydrogen to make it cost competitive with fossil fuels, and to realize our vision of a world where fossil fuels are no longer burnt. On this slide, you can see our electrolyzer today. It's about the size of a microwave. And as you can see on the graphic nearby, our electrolyzer sits at the very beginning of the hydrogen supply chain. Hydrogen effectively couples those hard to decarbonize sectors, and it provides flexibility as well. And our electrolyzers are being used, for example, to provide an alternative fuel for the mobility sector, because when we think about ships and planes, these are really difficult to electrify, and this is where hydrogen can play a role. At Enapter, we've understood that our electrolyzer is only one piece of the puzzle. Most often, it operates within an entire energy setup, and so ease of integration was critical for us. This is why we developed our energy management system. It enables remote monitoring and control, and it acts, the gateway acts as a translator of all of these different protocols and languages that these different devices have, because a solar panel, an inverter, a battery, a fuel cell, and a storage tank have been made by different manufacturers. And we need to make sure that all of these devices can communicate to each other and to be able to set rules. So for example, the sun is shining, start making hydrogen, or the storage tank is full, stop making hydrogen. Our electrolyzers and EMS are today running in over 30 countries and across all sectors. So I'd like to walk you through just a glimpse of our use cases in the next slide. In the top left, you have here the Pisoea House, which is a multi-house residential complex in northern Thailand in Chiang Mai. It generates solar energy during the day. When the batteries are fully charged, then it will start producing hydrogen. And at nighttime, it is using hydrogen via the fuel cells to provide electricity. This is a use case, for example, for seasonal storage. In Southeast Asia, there is rainy season. And so if there's no sunshine, this home has over 30 hours of autonomy. Moving to our right, in the middle, we have an image of the Mafat hydrogen microgrid, which is on the Reunion Island and completely inaccessible by car. So here we have a great use case of hydrogen providing long-term energy storage. Here, the community has over 16 days of autonomy. Now, to our right, we are moving into the power to heat sector. So here you can see our electrolyzers stacked in a project with DNVGL, actually, in the Netherlands, where our electrolyzers are generating green hydrogen to provide district heating to nearby apartments. In the bottom left, and this is one of our use cases in Australia, in Queensland. Our partners, Southern Green Gas, are coupling solar panels with our electrolyzers and CCS technology to generate green methane. So here we have a power to X example in the case here of green methane. Now, the two bottom right examples are in the mobility sector. As you can see, the hypercar by Hyperion and Zero Avia's hydrogen powertrain plane. Zero Avia just completed their first commercial flight test over the summer. And Val had mentioned the cost of hydrogen for planes is a lot cheaper, as you can have on-site production at airports through electrolysis. So we can see now how hydrogen can start decarbonizing the mobility sector as well. As I said, this is really just a glimpse of our use cases. But in the next slide, I'd like to share a bit in terms of where we are heading at Enapter. These use cases today are stacking electrolyzers, as you can see here on the cabinets, but we are already working on containerized solutions, whether it is to produce 70 kilograms a day or to go up to the 450 kilograms a day. The 450 is has a 1 megawatt input of electricity, and this is what we plan on scaling out in the next 3 years. So we believe that stacking individual modules presents many advantages in terms of flexibility and resiliency, because if any module has a problem, then you just hot swap it. It's not very complicated in terms of maintenance. I think this is a good introduction just to kick it off. And in my final slide, at Enapter, all of our focus is on bringing down the cost of hydrogen, and our goal is to bring it down to 1.5 euros per kilogram in the next 3 to 5 years. So with that, thank you very much. And I'd like to pass it on to Pras Ganesh, Program Director at Toyota Mobility Foundation.
Thank you very much. Thank you, Vaitea, and thank you for having me over here. So actually, of course, my name is Pras and I represent Toyota, but I'm also representing in some ways industry and talking about industry related to hydrogen. The subject that we kind of want to raise over here related to hydrogen is not something that is new. We've actually been talking about hydrogen, as was mentioned, for a long time, for over 50, 60 years. We've actually been talking about hydrogen. But the issue, and in fact, even we've had use cases, space travel, all of these things have been using hydrogen for a long time. But the point is, right now we have reached a particular moment where hydrogen is actually ready for commercialization and scaling up. And that's kind of one of the points that we absolutely believe. It's also because of the technology, it's also because of the scale, it's because of the fact that we've had enthusiasm from various stakeholders, but probably most importantly, the need for actually utilizing hydrogen for decarbonization is absolutely right. And that was the reason why the Hydrogen Council itself was started. And interestingly, and one of the reasons also I'm here is I was one of the founding members of the Hydrogen Council. And the Hydrogen Council is actually currently an organization of 92 companies representing about $22 trillion and 6.5 million jobs. And it's in that context when we start talking about hydrogen, and what the Hydrogen Council really kind of believes is that the attractiveness of hydrogen is like it's a Swiss Army knife of energy. What we mean by that is, as the council, we determined that there are 7 use cases for basically hydrogen, whether it comes to enabling large-scale efficient renewable energy integration, as Vaitea was mentioning, or distributing energy across sectors, like from Australia to other countries, or as a buffer to increase system resilience during winter or during rainy season, or about decarbonizing transport, used as a feedstock for industry, for feedstock for carbon capture, and also decarbonizing heating, or even residential or industrial heating. So there's multiple utilization cases for hydrogen in itself. And in that context, there are 3 kind of main primary drivers. The first one is really on energy security. And that is why hydrogen is a very attractive element. It can actually capture and store renewable energy, which is very important. And it also gives energy security. As you know, currently, globally, we have about 55 days of energy secure, and most of it is on fossil fuels. So hydrogen has actually the ability to transfer that and make it into renewable energy economic potential, not just in terms of the industry, as we're talking about electrolyzers or transportation or any of these kind of areas, but also in terms of trade. We can actually trade energy. Right now, fossil fuels allow trade for energy, but this is not necessarily possible just with electricity. So from that perspective, hydrogen actually can allow us to trade it. And then finally, there's the environmental imperatives, and hydrogen has the ability to kind of abate the more difficult to kind of abate CO2 areas. So especially if we're looking at heavy duty transportation, we're looking at shipping, we're looking at airlines, we're looking at steel, all of these kind of things really are very important that hydrogen works. This particular slide that you see just talks about the amount of energy actually that can be produced by hydrogen in 2050. This is based on a kind of study that we did, and also how much of the energy usage actually can be utilized through hydrogen. So there are certain sectors where actually we are already ready and we can do up to 80%. For example, even if we take something like forklifts, this is something that we can transfer to hydrogen today, and it can cover 80 to 90% of the entire forklift industry immediately. And similarly for different kinds of utilizations. And this image just gives us something that we can go on. So when it comes to transportation, which is kind of the area that I'm in, or it comes to mobility, this is something that absolutely hydrogen has to play a critical role, but hydrogen cannot be seen completely in isolation. When we look at kind of decarbonization of mobility, we try to look at it from 2 broad angles. The first one about the actual well-to-wheel kind of output of CO2, and the other one is actually the total distance driven. So it needs to look at energy utilization. Some countries which are more maybe fossil fuel generating, for energy, these are the areas that tend to kind of still maybe some elements of hybrids or plug-in hybrids are still very attractive for transportation and decarbonization. On the other hand, when it comes to areas where more renewable energy can be utilized quickly, these can go more for BEVs and also for hydrogen. And we think it's part of a total kind of mobility grid that we need to look at electricity, hydrogen, as well as fossil fuels integrated. In the bottom, you can just see various use cases that Toyota strongly believes in. Of course, when it comes to larger vehicles, longer distance vehicles, we believe that fuel cells are absolutely appropriate. Maybe shorter distance are okay for BEVs. For heavier weight, because obviously this is a key intent, the weight of the vehicle and the range of the vehicle. Heavier it is, longer range you need, it is better that it's hydrogen. A smaller distance, lighter vehicles can be battery electric. So these are some of the things that we do see. Buses, trucks, fuel cells, as we mentioned. And maybe just as a last word to conclude my opening primer comments, it started off in space. When we were talking about hydrogen, we started off that we used hydrogen to take us to space. And now actually Toyota is working on the Lunar Cruiser, which is basically a lunar probe, again, which utilizes hydrogen as actually a transportation. So that's the reason we see the utilization is very broad, and we are excited about hydrogen going forward. So with that, I'd like to hand over to Dr. Subodh to continue with the panel discussion. Thank you very much.
Thank you, Pras, and thank you all the panel members for wonderful inputs and a primer to hydrogen. I think we'll go slightly deeper into the individual areas, and just looking at the time, I think I'll start off with Vaitea. Vaitea, I think you represent the beginning of the hydrogen value chain in terms of the hydrogen generation. One of the key products of Enapter is electrolyzers. Could you tell us a little bit about the challenges in terms of the hydrogen generation, and where do you see the technological barriers that need to be overcome going forward?
Absolutely, thank you. I think starting with the first challenge today in terms of electrolysis has been the cost of electrolysis. To set the scene, as mentioned earlier, actually by Mathias, he did mention the, or Patrick, but it was mentioned that we have the traditional alkaline electrolyzer and the PEM electrolyzers today, and they've been the more mature technologies. The alkaline technology has the advantage that it is the more cheaper option. And the PEM technology provides flexibility, has a fast response time, and it's efficient. But it's efficient and has a good lifetime because it relies on platinum, gold, metal groups, and so it's expensive. At Enapter, as mentioned before, we are using a completely unique technology. It's the anion exchange membrane technology, AEM. And we are combining the benefits of the two. So we achieve a low-cost electrolyzer because we do not rely on any platinum or gold or radium for our electrolyzers to be highly efficient and to have a good performance. We still achieve high purity of hydrogen and also hydrogen that is pre-compressed at 35 bar. And also the environment in which it operates in is slightly alkaline, which enables a safer handling of the gases and a safer separation of the hydrogen and the oxygen. The water as well that we're using is doesn't need to be completely deionized. We can actually use filtered tap water, filtered rainwater and tap water. So this is kind of positioning now the AEM as a new technology that we believe has a huge potential, because unlike the PEM and the alkaline, we can still make significant technological improvements through R&D. One point that I'd also like to share in terms of where is this going, where is this technology going, why is it different than the others, is because the approach to scaling this technology is completely different than how it's been made before. We like to compare our unique approach by drawing an analogy between the IT industry in the 1980s and the electrolyzer industry today. So electrolyzers manufacturers are today building systems similar to the IT industry's early mainframes, these huge systems, right? And each of these are designed as a unique project which requires sophisticated engineering and planning. At Enapter, we're mimicking the approach and the introduction of the PC, a product that is standardized, modular, and scalable. nothing has seen more rapid cost reduction in economic history than mass-produced commodities. And this is our way at the moment with Enapter to mass-produce the AEM technology to drive down the cost of green hydrogen.
Great. Thanks, Vaitea. So, Patrick, if you don't mind, I'll go to you next. Hydrogen is just, generation of hydrogen is just the beginning. What do you do with it? How do you store it? How do you take it across the oceans? How do you address end use of hydrogen? Could you run us through these issues, please?
Sure, absolutely, and thanks very much for the opportunity to answer this rather complex question, because there are very many answers. So I'm going to try and distill it into a simple form. So the three main ways of storing hydrogen are compression, and Vaitea spoke about that, compression, and depending on how much you have to densify the hydrogen to transport it, you have to go to very high pressures, 70 megapascals for many of the vehicle fuel tanks. And then you can store it in high pressure tanks, and typically those high pressure tanks in vehicles are carbon fiber composite tanks that can withstand that very high pressure. The next way of densifying even further to get that hydrogen into the most compact form is to liquefy it. And that involves you cooling hydrogen down to minus 253 degrees Celsius. So that's very cold indeed. So lots of technology challenges in doing that, of course. And then the third way really of moving hydrogen is actually to store it and move it in the form of a chemical carrier. So there are a number of chemical carriers that people are researching. One that's particularly popular, one which we've done quite a lot of research on, is ammonia. So ammonia is again a very high density hydrogen carrier. Because it's a liquid at relatively ambient conditions, you can transport it and store it relatively easily. So there again, that transportation for chemical carriers is much easier, but there are challenges with chemical carriers too. And that relates to the cost in producing them, to reacting the hydrogen to produce them, and also the cost of recovering the hydrogen from them. So all of these different pathways for storing hydrogen, I guess, are being actively researched. Another way, a really simple way of moving hydrogen is actually to use the gas distribution networks that we have in many countries. So just simply piping hydrogen, using hydrogen to replace natural gas in gas pipelines, and moving it around that way. So that's existing infrastructure, of course, so relatively straightforward to do that. There are challenges in terms of the materials, etc., but that's something that's obviously being looked at, particularly in Australia and many other countries. Now, in terms of using hydrogen, numbers of different ways you can use it. You can use it in combustion processes. We've heard about heating, so you can use it in domestic heating, just like we use natural gas. So you can replace natural gas with hydrogen and burn it. And when you burn it, of course, you don't produce any greenhouse gases. There's no carbon dioxide emitted. It's just water. And you can do similar combustion processes in industrial processes too. So that's one area of utilization. You can produce it. You can use hydrogen to produce electricity, effectively by reversing some of those processes that Vaitea spoke about in fuel cells. And fuel cells is what powers hydrogen vehicles in particular, for instance. So essentially generating electricity back from hydrogen and using that to power electric motors. Finally, the last utilization is we can use it as a chemical feedstock, and that's really what we've been doing for many, many years, almost hundreds of years in industrial processes such as refining and ammonia production, as I mentioned. So there's a big opportunity to replace the existing brown and grey hydrogen that's used in those processes with clean and green hydrogen. So quite a few different answers for you there, I'm afraid, but hopefully that's summarized them for you.
Great, thanks, Patrick. Pras, I would love to go to you next. One of the use cases that Patrick mentioned was for fuel cell driven electric vehicles. Famously, Elon Musk has said, and I quote, this is what he said about fuel cells: success is simply not possible. So I would like to really pose this question to you. Do you agree with this statement? If yes, why? If not, why not?
So thank you very much. And before there is any misunderstanding, I would like to make it clear that we very much respect Mr. Musk, and he has actually been helpful to drive electrification. Toyota was one of the first companies to start electrification. We've been working on electrified vehicles from the 90s, before it was exciting or sexy to talk about electric vehicles. But at the same time, Mr. Musk has helped us kind of bring electrification really into the spotlight. But the one point I would like to mention is that Mr. Musk has an agenda also for why he is saying that, because it is, as far as he is concerned, he is looking at it purely as a zero-sum game between battery electric vehicles and fuel cell electric vehicles. And that's the reason why he always talks about the fact that fuel cell electric vehicles do not necessarily have the benefit of battery electric vehicles. But the reality, of course, as we have spoken about and discussed even briefly in my introductory comments, is that it depends on the use cases, very much so. In certain areas where they're harder to abate sectors, so especially long distance transportation, especially when it comes to heavy, more heavy duty utilization, these are kind of areas where we absolutely believe fuel cell are much more appropriate. The critical element that we need to understand also is that battery electric vehicles, of course, are good in shorter distance, shorter time, but you do need charging time. You need to look at the range, you need to look at the weight of the vehicle, you need to look at the charging time as well. So in certain areas where you need longer distance, where you need to make sure that you have a quicker kind of refueling time, in these kind of circumstances, definitely fuel cell electric vehicles make much more sense. So when it comes to fleet, these kind of areas, we believe that fuel cell has absolutely, you know, a lot of logic. And also from a cost perspective, we believe that especially for long distances and heavier weights, already the cost is now getting comparable, and fuel cell will have an advantage even going beyond that. So from that perspective, again, we understand what he's saying and why he's saying it, but I think we should look at it in a broader perspective and look at electrification based on the right use cases for the right kind of technology.
Thank you. So I think what we have covered so far is, I think tremendous progress is being made in generation of hydrogen, transportation, and use, including for fuel cell driven vehicles. So Mathias, if I may come back to you to say, hey, if so much progress is being made, what's the issue? What are the key barriers to adoption? Are the barriers technological? Are they political? Are they regulatory? Are they economic? Could you run us through the scenarios that need to be addressed, please?
Sure. So I think it's a mix of the points you just mentioned. There is, of course, a lot of vision about hydrogen, how hydrogen can help us. And if you ask me, I'm pretty sure it will play a significant role in the energy transition. But to get to that point, and I think we can see the same story, or we could see the same story with renewables 2-3 decades back, will require incentives, will require that people really create business cases where you can make money with that technology. Otherwise, all these nice things which are technically possible will not happen. So I guess the one big barrier obviously is safety. We have to tackle this, but that's a technical problem, and usually technical problem you can tackle. So I think that's just a matter of time. The cost of production may be another thing, but also there we see that's going down over time. We have seen that in wind and in solar. At the beginning, it was just a tree hugger industry, let's say like this. And today it's the big investment firms and whoever is going in there because it has become a real business case. And I think the same story is hydrogen, and that is where then policy and regulation really needs to kick in to also create a level playing field for companies, but also to really make it attractive. And then coming back to this staged approach, I think it's important that we do not go gung-ho green. That's all we want. That will probably not work or will be incredibly slow. We need to make sure that the pathway is properly formulated so that we have a chance for this whole blue hydrogen, which comes with incredible advantages in itself already, because you can now decarbonize centrally rather than at all the different use cases, for example. So there's a role for this. And then really, I think I mentioned that at the beginning, this whole discussion about a carbon price, I feel is quite important to also make companies move into this direction. And then maybe lastly, taking risk out of investments. So getting, good tariffs together, for example, how do we do billing on volume or on energy content? All these small things which will at the end of the day decide if it is viable to do this or not. That even we all understand it's good to do this to save the world. Unfortunately, that also didn't help renewables in the past. To make progress, it needs to become something where people at the bottom line have some profits left. And I think these are the barriers we have to overcome.
Great, thank you, Matthias. I have another few sets of questions before we go to the concluding remarks. The only request I have this time around is, can you please keep your responses short, perhaps just limit it to 1 or 1.5 minutes each. I'd like to start off with Patrick this time. I think as Patrick, as you know, in March 2020, the Prime Ministers of Australia and Singapore agreed to drive cooperation in low emission solutions. This includes development of hydrogen markets. Can you comment on what can we see in terms of our bilateral relationships between Australia and Singapore with regards to collaboration on hydrogen?
Okay, I can do my best. The one thing I can't do though is really speak for our government, so I'll give it my best shot. I guess I would just turn to what the MOU talks about between Australia and Singapore, which really references several areas of cooperation: low carbon hydrogen, obviously, carbon capture and storage and utilization, renewable energy trade, and measuring, reporting, and verification around some of these energy areas. So these are all very important areas, and areas where we're very interested too, of course. So I guess from the CSIRO perspective, I can certainly tell you where we would like to see collaboration, and we are collaborating, of course. We're actively pursuing research collaboration with Singapore. We're working with NTU to look at hydrogen hub concepts around the use of ammonia, which I mentioned previously, as a fuel, particularly in things like stationary power generation and in maritime applications. So some nice areas there. And yeah, look, I might just leave it there. That's enough to start with, I think.
Thanks, Patrick. Thanks for keeping it short. Pras, if I may go to you. We have spoken about transportation and infrastructure. Can you elaborate a little bit more on what needs to be done to address both of these issues to really make hydrogen a viable solution in both transportation as well as in other broader use cases?
Thank you very much. So I think the critical element that we need to work on, of course, there are probably 4 main stakeholders that we have to look at. We have to look at policymakers, so we need some kind of regulatory support, as was mentioned. We need financial incentives for people to continue to invest into this particular area and bring down costs. We need industry commitment to get into this particular space, and we need consumers to have a better understanding and awareness to make, and it has to make business sense, of course, for them to also opt for a hydrogen solution. So if we start looking at transportation, again, very briefly, the critical elements that we need to look at is, one is the production and distribution of hydrogen, how to bring the cost to be as viable as possible. And there people like Vaitea and others are working very hard to try and bring the cost down appropriately. As renewable costs come down, distribution costs come down, we are starting to see that this is going to make a lot of economic sense within the next 10 years or so. And then from a perspective of hydrogen refueling stations, where we do need to have sufficient infrastructure. It's a bit of a chicken and egg situation. You need the refueling in order to get the transportation out there, but you need the transport to also make the refueling stations make sense. So that's the reason why governments and industry have been collaborating to set it up. But what we do see is the start maybe a lot on fleet, some kind of fleet where infrastructure can be simpler to roll it out and then build it up from there. So I'll just leave it over there, but I think that kind of gives a gist of what we are kind of working on.
Great, perfect, Pras. So let me go next to Vaitea. Vaitea, you are a trailblazer, not just from the perspective of coming up with new ideas and concepts for hydrogen generation, but also from a startup perspective. So can you speak a little bit about, what are the challenges and need to be addressed, and how does entrepreneurship play a role in the hydrogen economy?
Absolutely, thanks for asking. I think what we've noticed today as an electrolyzer manufacturer and looking at our hydrogen industry is that there's a lack of ecosystem. People are doing a lot of different things, and we're missing these bridges and connections between either companies but also countries. And so I feel like new startups could really create these bridges, either by building a product, but also by providing services such as system integration, for example. I think another opportunity for hydrogen startups could also be starting to unlock new business models. It could be, for example, rental of the different devices. In the future, we can even consider peer-to-peer energy trading. So these are just the kinds of visions that we can have in terms of roles of entrepreneurs in hydrogen. As a startup in this quite old industry, it's enabled us to be nimble, to act fast, and to really innovate, and also to bring a completely different product and to market it differently, in the sense that one of our modules costs less than 10,000 euros. So when you're selling one, rather than having to talk about a minimum investment, which is much higher, usually in the 6 figures, our customers are tempted and usually do buy 3 to 5 to 10 electrolyzers to prototype a system and just play with it. So it's really helpful to have this kind of module and to position it in this way, to use green hydrogen across all applications, from residential, but even into the ammonia production industry. And also a tip to all entrepreneurs is building your network in terms of your partners is super important. As a technology provider, we've made sure to also develop a partners network to provide the customer service and to provide also the maintenance and the integration of the hydrogen to provide turnkey hydrogen solutions.
Great, thank you, Vaitea. Mathias, if I may ask you a question. From your experience in DNVGL, you are really you play the role of being a technical advisor. You advise governments, you advise businesses, decision makers. So what needs to be done to accelerate the transition towards a hydrogen energy future?
So I think one thing we are doing right now is also to bring the different players in the ecosystem together in joint industry projects to really work together on solutions in environments which allow for trying things out, which allow also to discuss maybe what somebody else has to do to enable somebody, another company to do their right thing. So I think this whole thing about getting the different stakeholders in this ecosystem together and creating the pathway forward where everybody gets a fair share of this to happen is important. And I think with our guidelines, we try to do this, which are of course a lot looking into technical introductory risk minimization and safety, but really kind of being that platform and then having projects like within Enapter, for example, where we then also really see the stuff working in the field. I guess that's the role we see for us here. That's what we have always done in the different industries. And it is a pleasure to do this in this case because it fits so nicely in this whole moving to a sustainable future thought, which is driving DNVGL. So hence, I think as long as we are all sitting together like we did today in this panel, I have learned a lot from my colleagues here, discuss these matters, overcome the technical barriers, the regulatory barriers. There's a great future for hydrogen to play an important role in the energy transition as a whole.
Great. Thank you, Mathias. I think I'm just going to move towards the concluding part. And I would like to pose a couple of questions and I would like each one of you to respond to them. Firstly, what's your hope to see from a global hydrogen industry perspective? What needs to happen over the next decade? Then relating to that, there's a target that Vaitea mentioned of 1.5 euros per kilogram. What needs to be done to really hit those targets? And finally, can someone comment also on really the nexus between hydrogen and carbon utilization or industry aspects of all of this equation as well? So I'm sort of rolling 3 questions into one, and perhaps we could go back and start off, if you don't mind, firstly with Patrick, then with Vaitea, Pras, and then end up with Mathias. So Patrick, do you want to kick this off, please? What do you see in the next decade?
Yeah, I think the answers to all of those questions is scale up. I think scale up is the key. We have to scale up. I mean, we're trying to build entirely new value chains, and we're going to need to scale up demand, and we're going to need to scale up supply so that the costs come down to satisfy that demand. So I think it really is all about scale up at this stage, and trying to build plants that at scale, and that's, you know, an example of that is what's going on in Australia at the moment. The latest funding round from one of our government agencies, the Australian Renewable Energy Agency, was all about large scale electrolysis, so pushing up towards that 10 plus megawatt scale, and then you're starting to produce, you know, significant quantities of hydrogen that you can start using in really large scale applications. So I think, yeah, for me, it's all about scale up.
So if I may jump in there and ask a follow-up question. So are you suggesting that that all the R&D barriers have been overcome and all that is left is scaling up?
No, I think not at all. No, I think there's plenty of opportunities for research and development, and we obviously we're looking at those, and they're in different aspects of the different value chains, as I touched on. So we've got to get the costs, you know, cost and efficiency, you know, is all wrapped up in this equation as well. So particularly when we're thinking about export, you know, these are complex export value chains involving multiple steps, completely new technology. And so there's a huge amount of R&D required to really get those technologies commercially ready, I think. So on the pure production side, you know, we've got some pretty good solutions, but there's more coming, like Vaitea's solution. I think in that area, and Vaitea touched on it, the manufacturability of some of this technology is going to be where the real cost improvements can be realized, and I think that's, you know, there's plenty of research in improving manufacturability as well.
Great.
So yeah.
Thanks, Patrick. Vaitea, over to you, please.
Yeah, I can only echo everything that's just been said by Patrick. It's clear, right? We do need to scale up, and this is exactly the direction in which we are going towards. We recently announced the location of our campus, where we will house the mass production facility of our electrolyzers, where on a yearly basis, we will start off by hundreds and thousands of electrolyzers. And we see this campus in Saarbeck in North Rhine-Westphalia in Germany as a blueprint for mass production of AEM electrolyzers, so that it's not only happening in Germany, but it can also go to Asia. It can go across all different continents, so that we really provide this blueprint on how to mass produce cost-efficient electrolyzers. And yeah, I mean, the vision for this is to scale up production. And also one point is that this new facility will house 300 colleagues. So anyone who wants to join the hydrogen field, there's a lot of jobs being created, and Enapter is always hiring.
Vaitea, just a follow-up quick question. Do you see more distributed generation of hydrogen, or do you see more centralized where you have large electrolyzers and plants like that? Which way do you see the market moving?
You see, it's interesting because the latest Bloomberg New Energy Finance report did show in terms of the energy production. And so you had this curve where it went really, really high into the megawatts and the terawatts, but then you also had this small peak and like 1 to 10 kilowatts. And it was just super interesting because it shows that there will be a trend towards decentralized already today, and it will also keep growing. So right now we are focusing on the decentralized hydrogen production, but it'll move, I think, in both it will increase.
Okay, great. Thank you, Vaitea. Pras, over to you. Can you comment on some of the trends that you see happening over the next decade?
So I think maybe to look into the future, I'd like to take a step back as well. Honestly, when initially we were starting to work on some of the hydrogen activities, I have to tell you, it was a bit lonely, because when we even started the, at the time when we were looking at Hydrogen Council, there was some movement in California, there was some movement in Germany, Japan was moving on hydrogen. And initially 2016 and January 2017, when we launched the council, there were about 13 companies, and we had to go to these 13 companies and request them to join. But as we have seen, just within the past 3 years, the number of companies who've joined, it's gone up to 92. All major companies from actually across the entire spectrum, from manufacture, transportation, distribution, and utilization, are starting to get on board, which gives me a lot of confidence. And especially if you start looking at certain countries like China, We're starting to see countries like India, other countries are taking a lot of interest in hydrogen because they recognize its potential. Germany's New Deal, I mean, the European Union also is making some significant progress on this particular space. So we are actually very confident that we do see the next 10 years is going to be one of the key tipping points, especially on cost. And then from 2030 to 2050, I think we will see a lot of sectors actually moving to hydrogen because it makes a lot of sense. So I'm very positive about it. And as was mentioned earlier, this kind of a forum or talking about hydrogen and getting people to get excited. I think hydrogen actually is a bit of a bug. If you get the hydrogen bug, it's very difficult to kind of give up. So I think a lot of people who start studying hydrogen will realize its potential and will get excited about it and hopefully contribute to making the transition to hydrogen kind of ecosystem as well.
Okay, great. Thank you, Pras. Matthias, final questions for you, of course, for the next decade. But I also realized there are a couple of topics we didn't talk about, and I wonder if you could touch upon those very in brief. We didn't talk about hydrogen for maritime transportation. I wonder if you can speak about that. And the second topic we didn't talk about is really the possibility of going to hydrocarbons as a carbon utilization aspect. So I don't know if you can cover both of those, but do tell us what you see in the next 10 years. What's your hope for the hydrogen economy?
Yes. So maybe I start with a general answer. What I wanted to add to the colleagues was, I think, drawing the parallel to what we have seen, for example, in the offshore wind industry, which at that time when it started was seen as a very risky thing to do. It's time for pilots. It's time for companies taking responsibility now to also drive things forward. I think especially the oil majors have the deep pockets to do this, so that we really have fast learning in the next couple of years, which we can then harvest so much from for the development going forward. And as we know, we don't have much time. I think everybody is telling us this now. We need these solutions pretty quick if we want to get the climate change under control with a good energy transition. If it comes to maritime, I think we saw that on one of the slides already for one of our colleagues. We do see, fortunately, industry taking some responsibility there here in the north of Germany, in Denmark, for example. There is a nice project with Ørsted who want to produce green hydrogen with renewables, and they have even aviation with SAS on board, but also the ferry operators around Copenhagen who then want to try to run their ships with hydrogen. And if I'm not wrong, I think there is also a project in Norway where a smaller container ship is using is using hydrogen for the transport in fjords. So I think, but this is exactly that what needs to happen: doing the pilots, learn from this, and hopefully having the ability to scale it up. Airbus is now working on 3 different models of planes who may use hydrogen in future. That will take some time before that happens. But I think these are the important things that we now start the really fast-paced learning and having people kind of push each other by, getting the motivation up to get this done without making it a hype again, which then it's just lying to ourselves. Stop there.
Great. Thank you so much. I'd really like to thank the entire panel for joining today's session. The last thing I just want to share with you is how important hydrogen is for Singapore. Singapore has set its target for 2050 for reducing our emissions from 66 metric tons to 33 metric tons. And the only way we can do that is really by leveraging the potential hydrogen offers. And for us to do that, we really have to solve and answer every question that we discussed today, right from the generation, right from how do you move hydrogen from where it is generated, perhaps in Australia or the Middle East or the US, how do you move it to Singapore? How do you store it in Singapore? How do you use it in the power sector? How do you use it in the industrial sector? So all of these topics is are topics which are critical for Singapore's long-term emissions targets. And I think the hydrogen economy would play an invaluable role in that context. So I'd like to thank all of you once again, and I echo the comments made by my colleagues This has been a very valuable learning experience for me. And thank you for sharing your knowledge and your wisdom with us. And have a good afternoon. Bye-bye for now.